Well, we are lucky enough to be joined here by Jamie Milne. He is the Big Data Manager with Worldwide Technology. And we're really excited to have him here, to have Worldwide Technology support with the program here. I mean, they're one of the leaders in artificial intelligence. And we wanted to invite Jamie here to the stage to talk a little bit about one of the use cases that Worldwide Technology is dealing with NASCAR, which I thought was really exciting. But also, I wanted to kind of talk a little bit about how Worldwide Technology is working with different government partners. So first, let me give a really brief introduction to Jamie. Jamie has a MS in astrophysics from University of Cambridge, which I thought was really interesting. And he worked with data coming off the James Clerk Maxwell telescope in Hawaii during your master's there, during your MS there. So I thought that was really interesting. I kind of geek out on space here and there. So Jamie, could you start off by talking a little bit about what WWT works with when it comes to government partnerships with big data in your big data manager role?
So thank you for the intro. WWT is an end-to-end technology solutions provider. My group, my team is really focused on analytics and that kind of mission focus that Dr. Cott was talking about as well. Previously we were the big data team. A couple of years ago we were the AI team. Eventually, that's what we're talking about today. Tomorrow, maybe something else. We're really the analytics team. We focus on that mission. So we have folks who are really figuring out that mission, turning a mission problem or a mission challenge or objective into a math problem. We have folks who take that math problem and solve it, your data scientists, whether they're using AI or traditional methods. And then we have folks who can enable that technology and kind of make it happen from an infrastructure perspective, leveraging, also was mentioned with one of the panels, having that GPU technology or high-end storage and compute to be able to make that happen. We have the ability to not only come up with and figure out what the problems are, solve them in a mathematical way, but actually deliver it and make it happen.
Okay. So when Jamie and I first talked a little bit about what we wanted to feature here at the event, it was kind of interesting. Quick background on me. Before I worked here, government CI media, I was an Air Force intelligence officer, and I kind of learned a little bit about what Jamie was working with a program that's connected to NASCAR. Now, I connect Air Force and NASCAR because when I was in the Air Force, especially in intelligence, they always said, hey, we want to be able to operate more like NASCAR or NFL when it comes to some of these big data issues. So I thought it'd be really interesting to talk about the program that they're dealing with Richard Petty Motorsports Group. So could you give a little introduction about how WWT and Richard Petty Motorsports started working together?
Yeah, absolutely. So WWT is a sponsor of RPM, and we're, my group and has been involved in that. We're very intellectually curious, and as we're getting as part of that partnership sponsorship model, we're figuring out how do they operate, what do they do. Turns out they've got a really kind of strict kind of supply chain business from testing, running practices all the way through race day. And like every organization, they're trying to consume as much data as possible, turn that into insights, and then ultimately use those insights to drive whatever strategy or whatever action they want to take that's going to ultimately give them the competitive advantage. So we worked with them. We wanted to figure out what their main pain points were. It turned out from an AI perspective, they were taking a lot of race imagery, a lot of high-resolution images of the race, and that comes to them in a very rudimentary fashion. It's just all imagery that's taken centrally by NASCAR is dumped in folders somewhere for someone to go out and look at. And I'll set myself up for failure by defining AI kind of off the bat, right? But one of the ways to look at AI is how to replicate human decision making, but using a computer. So what we were taking was trying to automate that process from they only have a very small pit crew whose job it is to make sure that the race is going well, but also setting up the race as part of that supply chain. And a significant amount of time and effort and people is spent combing through these photos, trying to figure out, okay, where do I identify the car? Then they're looking for the car themselves. They're looking at, okay, am I hitting the corners correctly?
Yeah.
Where am I in respect to my competitors? What kind of damage can I see in the cars? Any other things that you can see visually from this high-res image? So we're able to use AI and some neural networks to identify automatically where the car was on those images, and provide the folks on the team, okay, here are the images that you have, and now you can look at them and figure out where they are. Next steps is really to zone in, now that we've identified those images, is to identify where the anomalies are, whether that's anomalies, again, going back to the mission. The mission is to make sure the car is operating mechanically well. So looking see if you can identify those faults or any issues. Make sure the cars are being driven in the right way. So see where they're positioning on the track and things like that. So we're using AI and ends to deep learning to figure out that and automate that. So it's with a lot of these things, it's really augmenting of the manual process. So the folks are. Ultimately, these folks who are working for NASCAR are at the top of their game, are incredible analysts at figuring out what needs to be done, but they spend 60 to 80% doing the admin of going out the data and rationalizing it in their mind. And that's the same across any organization, whether it's commercial or federal. A lot of work, we have these, myself internally, our team has these fantastic data scientists who do incredible work, but they spend 80% of their time wading through data, trying to get the definitions right, trying to combine these data sets. And that's exactly what we're doing, but in the race setting.
And that's what I thought when you guys were explaining the program. I thought back to my time of having so many of these Air Force imagery analysts looking at imagery sets coming in from, the collections from like the Predators or the Reapers and whatnot. And it just seemed to me that it just was a complete connection there, where the same way that those folks were looking at imagery from the races, and making them more efficient, making it a lot easier. I think there was a statistic where the Air Force was saying that they were only looking at about 6 to 7% of the actual intelligence that was coming in, because humans can only look at so much there. But with like a system like this, it seems like that number can skyrocket quickly. So I think that's really interesting.
Absolutely. It's about getting them the right information to the right people as quickly as possible. You could say that, that the healthcare panel here as well, I heard that your average radiologist looks at an image every 8 seconds to figure that out. So if you can get that person, whether it's a radiologist or an Air Force analyst or a NASCAR pit team, if you can get them the right images faster, or maybe draw their attention to any anomalies or specific areas of that image that quicker, that's going to save them, it's just going to save them a ton of time, make them more effective, and maybe even make it a little bit more risk-proof as well.
Out of the program, and now when you were coming to some of the conclusions from it, were there any results that really stood out to you?
There were a couple of cool things. Number one, just seeing it at the race day. That's one of the benefits of being the sponsors. Everyone is scrambling to get there. We're in the pit itself. It's just a really neat thing. But seeing the results, seeing we also did a lot of UI work for them. So they're using this dashboard, but you can literally see the folks previously who were combing through Dropbox folders looking for files are just having these images pop up, and they're making decisions based on the work that we've done. You can see that and kind of touch it and figure out that benefit. A couple of the geekier things, or I would say cooler things, we, as part of the work itself, our data scientists are really lazy. That's a really good. There's a Bill Gates quote, I think, about how he doesn't hire smart people, he hires lazy people. Because a smart person will figure out, right? Going back to the point again on the mission, a smart person will try and figure out all the complicated ways to do it. A lazy person will figure out how to get their job done easier.
So which one are you?
I'm very lazy. So we have these data scientists. A big challenge for image analysis or any unstructured analysis really is tagging of the data. So okay, if I'm looking at this image, I know that that's car number 43 was the one we were looking for. Or if I know, for a radiologist, right, I know that this is a particular, whatever type of medical anomaly you're looking for. Or for an Air Force person, this is what a missile silo looks like. There pretty much always has to be some human input there. So what we did that was really cool was we created our own app to tag the data manually ourselves. Okay. And we produced it in a way that we were showing, we ran a kind of preliminary model which was very rough and basic, but would provide hundreds of images on the screen and allowed our folks, myself included, we kind of crowdsourced it as a team to find where the model was getting it wrong or not.
Okay.
So we were able to tag hundreds of images at one time, find the anomalies, click through, keep doing it, and once you do that kind of reinforcement learning, that really strengthens the model and makes it faster. But that was a cool kind of application we developed because a lot of folks that we're seeing maybe want to do that, want to do image analysis, but don't necessarily have those targets or those tags that you really need to be able to do that. So that's kind of a shortcut that we would be applicable across any space that we enjoy doing. So that was a neat kind of time saver for our team and got us very excited about that. Another piece was this was more fun stuff, or I guess R&D, if you want to be like super corporate about it. Right. But we used GANs, so adversarial networks, to create dummy data out of the NASCAR imagery files. So we took the 10,000 NASCAR images and used this new kind of completely new, but it seems to be rising to prominence very quickly. Use this GAN algorithm to create dummy data based on the NASCAR data. So actually, you can multiply your data set and provide yourself with more training to be able to run that. Another some interesting industry implications for that is it works on imagery very well. So you're basically taking an image set, creating new images that look very similar to the other data, but they're not. They're just dummy data. But that's got a lot of implications for PII, for sensitive information, where if you want to leverage commercial data scientists, or you want to leverage other folks who either aren't cleared for that data, or you want to host it in a platform that's not secured, right? Obviously, security is a big focus in the government space for lots of very valid reasons. But we're starting to use these networks that create this dummy data in an intelligent way, using that sensitive data. Okay. So we can now have folks either use it for testing of infrastructure in our lab, or we can have our data scientists who maybe aren't cleared or haven't got whatever reason to look at that data, or just because, frankly, it's quicker to do that, right? If you're using dummy data, you can get approval very easily. If you want to use PII data, you have to go through all these formalities. So that was a cool thing. Discovering and getting to play around with that kind of technique has really opened up a lot of doors for us to kind of cut the red tape of this kind of AI processing, because there are all those ethical questions, and thinking about how the machine interprets or how it disseminates that information kind of hopefully becomes a little bit of a kind of shortcut to be able to do that.
Okay. Well, thank you very much, Jamie, for sharing a little bit about the NASCAR program and what you guys are doing with Worldwide Technology. I think it's a perfect transition to our next panel here and our final panel of the day, the National Security Panel.